Hello, 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 and welcome back to Shiksha DaCosta. Today we're going to learn how to identify exponential relations. So in this lesson, we're going to learn how to tell three different types of relationships apart from each other. Some relationships are linear, some are quadratic, and some, like we're learning in this unit, are exponential. And you're good at this when you can distinguish, which means you can figure out which one is which, when you can distinguish exponential relationships from the other two by making comparisons in a variety of ways. Just to get our minds in the right space, let's think about this example question here. In some video games, players collect experience points, or XP, and when they have enough, they get stronger, or in other words, they level up, they get into the next level. And that makes the character that they're playing as pretty strong. But to do that, to collect that XP, they usually defeat monsters or maybe they complete tasks. So what I'd like you to do is take a look at these three games here, Balthazar's Gate 1, 2, and 3, where the designers of the game have different requirements for how much experience a player needs to get to each level. Make a scatter plot for each of these and draw a smooth curve through those points. And we're going to compare these three graphs to see what were the designers thinking when they changed the XP requirements from the first game to the second, and from the second to the third. And what were they trying to accomplish? You can pause this for just about 5, maybe 10 minutes, or however long you need to draw these scatter plots, and then we'll pick it up right after. All right, hopefully that was enough time. Let's take a look at what these scatter plots might look like. So for Balthazar's Gate 1, write 1 and 15. I'm just going to plot that right over there, 1 and 15. 2 and 30. Let's continue plotting all of these. 3 and 45 would go right over there. 4 and 60. At level 4, you need 60 XP, and 5 and 75. All of these points, if you notice, are in a perfectly straight line. And we could draw a line that goes right through them just like that. For Balthazar's Gate 2, for level 1, you still need 15 experience, so that's the same. But for level 2 now, we need a little bit more, that's 45. Now, these 2 points are in a straight line. Between any 2 points is a straight line. But what happens when we start adding more? 3 and 90. 4 and 150 is a little bit higher than that. And 5 and 225 is even higher than that. And if you notice, these aren't exactly in a straight line. They follow a very, very slight curve upwards. Every time the level increases by once, the amount of XP that you need doesn't increase by the same amount. Here it's 15 more experience for each level. But here you need 30, and then 45, and then 60, and then 75 more experience. So the distance between these 2 points, the vertical distance, seems to be increasing. And it's not super obvious by looking at the graph, but if we look at these 2 points, the blue and purple, compared to the red and yellow, we can see, oh yeah, these ones are actually much further apart vertically. In Balthazar's Gate 3, they changed the level requirements again, and now 1 and 3 would be really close to the x-axis. 2 and 9 would also. 3 and 27, okay, now it's starting to increase just a little bit. 4 and 81, 5 and 253. This curve is much sharper over here than this one is. This one was a little bit smoother. And in fact, this is the difference between 3 different types of relationships. The first one, because all of the points form a perfectly straight line, is called a linear relationship. Literally, the word line is right in it. This one is called quadratic, and that's not really part of this unit, so we're not going to get too far into why we call that quadratic. But this one is the one that we want to focus on. This is an exponential relation. In a linear relationship, like I mentioned, the y values always increase by the same amount. Every time, if x increases by the same amount, the y values also will increase by the exact same number every single time. But for a quadratic relationship, we notice that even though These are called the first differences. Even though these differences are not the same, the difference between these numbers is the same. To get from 30 to 45 is plus 15. From 45 to 60 is plus 15 again. From 60 to 75 is also plus 15. But for an exponential relationship, like we studied in our previous lesson, to get from one y value to the next, you multiply by the same number. So 3 times 3, instead of adding, we're multiplying. 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81, and 81 times 3 is 243. These values are called the first differences. And the way you find a first difference, remember, difference means you subtract. All you have to do is subtract the two y values. So you take any y value, y2, and you subtract the y value before it, y1. 90 minus 45, that's how I get 45. 75 minus 60, that's how I get 15. That's how you calculate something called the first differences. There is something called the second differences. And second differences are calculated by subtracting the consecutive first differences. So if I took 45 and I subtracted 30, I would get 15. If I took 75 and subtracted 60, I still get 15. Notice in a linear relationship, the first differences were always the same number. In a quadratic relationship, the second differences are always the same number. But we're going to focus on exponential relationships. And an exponential relationship does not have the same number for its first differences. It doesn't have the same number for its second differences either. It has the same first ratios. And a ratio, of course, is the division of two numbers. So just like I subtracted to find the difference, to find the ratio, I will divide these two numbers. So 9 divided by 3 is 3. 27 divided by 9 is also 3. 81 divided by 27 is 3, and 243 divided by 81 is 3. These first ratios are always the same. That's how I know that this is an exponential relation. For linear equations, you may know these already. An equation might look like something like this, where you have 15 times x. 15 is the number that it goes up every single time that x increases by 1. In a quadratic relationship, it may look something like this, 15 times x squared. In fact, the word quadratic comes from the Latin word quadratum, which means square. An exponential relationship may look like this, where the independent variable is in the exponent. So once again, for a quadratic relationship, there is an x squared term. That's how you know. If you're looking at the equation, that's how you know that it's quadratic. If there's something that is x squared, the exponent is always 2. How do you know if it's exponential? If the independent variable is actually in the exponent, not in the base. That's how you know that the relationship is exponential. The easiest one is linear, right? X, if you're just multiplying by x each time, that means that it's linear. These are we looked at 3 different ways of expressing 3 different types of relationships today. First, we looked at the graph, then we looked at the table of values, and then we looked at the equation itself. And really, we want to focus on the exponential one. Exponential relationships have constant first ratios. That means that when you divide any 2 consecutive y values, you always get the same ratio. 9 divided by 3 is 3. 27 divided by 9 is 3. And so on and so forth. Any 2 consecutive y values, if you divide them in the same direction, y2 divided by y1, you always get the same number. The equation of an exponential relation will always have the independent variable, which is usually x, in the exponent. So this would actually be 3 to the power of x. The first ratios are 3, so we're multiplying by 3 again and again and again. So this would be 3 to the power of x. Right there is my independent variable in the exponent. So in the previous lesson, we learned about how to tell it's an exponential relation from its graph. Now we know how to tell from a table of values and from an equation. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.